Okay, so if you are cool with the homework for 5.3, it's due at 1 o'clock, so you've got a couple hours to finish it up. And you can just peel out. So that's pretty much what we're done for 5.4 today. Hop out whenever you want. If you do have questions on 5.3, now is the time to ask. So I'm happy to help with that.
Can we do number 25?
Mm-hmm. Okay, so all right, that one. Okay, so the numbers at the top and the bottom tell me that I'm going to go 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. What do I do with those numbers is I plug them into the pattern. And so the pattern is 11 is the first one. I just put in 11. And then 12 and 13 and all the way down to 20. And yeah, I mean, you could just add them up, but that's defeating the purpose. So what they wanted you to do is start at 1, 2, 3, 4, add up to 20, and you're like, that's not the right answer. But if you took away 1 through 10, so subtracted off 1, 2, 3, up to 10, then you would have the numbers 11 to 20. And now this is exactly the pattern. If you go 1, 2, 3, 4, all the way up to 20, you can plug that into the pattern, which is you take the last number, 20 times 20 plus 1, divide it by 2. And then the same thing over here. Your 1, 2, 3, all the way up to 10 will be 10 times 10 plus 1, all divided by 2. And you can subtract those 2 off. So this completed, this would be 10 times 21. This would be, I think we did that one in class, 5 times 11. So 210 minus 55, 155. Make sense?
Yeah, that makes sense. Thank you. I guess I thought about it too much.
Yeah, that's easy to do in math classes. You're like, that's got to be harder than this.
So basically for that problem, because what I did initially was add them up, but so you just took out all the 10's values and just added all the 1's values. So it would just go from 1 to it would just go from 1 to 20, and for 10 it would just go from 1 to 10.
Yeah. So let's see. So,
If so, wouldn't it just be 10 times all those values? Like it would just be 10 times 1 plus 2 plus 3 plus 4 plus 5 into 10.
Yeah, so let's see, if you did strip off just the 1's digits, you'd have 1, 2, 3, 4, all the way up to 10. But then what would be left? Like a bunch of 10's, right?
Yeah, that's what I was saying. We went to basically just a bunch of 10's at this time. That's what I was a little confused about.
Yeah, that works as well. So if you wanted to do the same thing, that first row would be 10 times the 11 over 2. The bottom row would just be 10 copies of 10. So 10 plus 10 plus 10, that's just 10 times 10. So that would be 55 plus 100, and you'd still get 155.
Okay, because I got the right answer, but I was just wondering with the method, because there's actually something I was kind of noticing. As for instance, on problem 29, I reviewed the book earlier before class started, and there was this method which involved the X and I's for right, left, and midpoints. And I basically just ended up using that rule rather than the rule we kind of learned in class. But I still ended up getting the right answer.
Yeah, I'm definitely not one of those teachers that's like, you didn't do it the right way. I don't care. I mean, yeah, if you do it a way that makes sense and can explain it, I'm totally cool with that.
Okay, I was wondering.
Yeah.
Sir, can you show me how to do number 29? I
Sure.
feel like I didn't use the left hand rule properly.
Okay. So 29 from you know, now that we have the fundamental theorem of calculus, you're like, why am I doing this? Because you just come over here and you're like, let's see, what's the capital F? Capital F is, I take the antiderivative, and then I just plug in 3, and I plug in minus 3, and I'll get 9, and I'll get minus 9, but then I subtract it. And so the overall answer is just going to be 18. And you're like, I'm done. But, you know, you gotta pay the piper here a little bit on this. So let's see, it says 6 rectangles using the left-hand rule. So I'm gonna go ahead and draw it. I wanna draw y equals x squared. I've learned I can't talk and draw at the same time. So this is 3, this is minus 3. If I chopped it into 6 pieces, it's nice that it's just straight up on the unit digits here. So if I went on the left-hand rule, so for each of these intervals, I go to the left point. So on this one, I go here, I go up, hit the curve, go over, and then make my rectangle based on that. Same thing here. I go to the left, I go up to the curve, I go over, I come back down. On this one, I go up, I go over, I come back down. These are terrible. They're supposed to all be spaced 1 apart. But on this interval here, I go to the left side, which is 0, and I don't go up at all because I can't. I'm right on the curve already. So that part's going to give me 0 area. This one, I go up and over. This one, I go up and over. And there's my 6. 1, 2, 3, 4, 5, 6. And then you just add up those 6 areas. Is that what you did?
Yeah, I didn't set up the rectangle because I wasn't sure how to do it either.
Okay. Yeah, so you just draw the picture, chop your little pieces down here into however many you need, 6, 4, 20, whatever. And then on each one, just start on the left side, go up to the curve. Once you hit the curve, there's your rectangle. So, I mean, just for kicks, what are these areas in here? It's 1 wide and it's 9 tall. So if I plugged in -3 into my function, I'd be 9 units up. So this is 1 by 9. What's the next one? What's this one?
-2 by 4.
Well, if I take negative, so the width is 1. And what's the height?
4.
What is it?
The height is 4.
Yeah, thank you. Right, so it's 1 by 4. So that means the area of that one would be 4. Keep going. The next area is 1 wide. It would be 1 high. So that would be 1. The next one is 0 because there's no rectangle there. The next one, if I go, should have drawn this a lot better, but these two are the same. So I go up 1, the width is still 1, so that area is 1. And the last one here is 4. So I get 9 plus 4 plus 1 plus 1 plus 4, which is 19, I think. So it kind of balances out, like this rectangle gets most of the area but gives a little bit too much. Same thing on the next one, same thing on the next one. But then on the back side, this one doesn't give enough, this one doesn't give enough, you're missing some. So it's not quite that they balance out. The correct answer is 18, but it's pretty close.
So that's all I had to do for the left-hand rule.
Mm-hmm.
And the right-hand rule is like, is it like almost like the same thing?
Yeah, for this one, I mean, if we just drew it very, very poorly here, but 1, 2, 3, you would, instead of going to here, you go to the right side of the interval, and so when you go up, you get this. So you can see it's different. And then the next one, you go to the right, up and over. Here, you get nothing, because it's supposed to come down and hit. Here you go to the right, you go up and over. Here you go to the right, you go up and over. Here you go to the right, you go up and over. So because this is nice and symmetric, it really will just end up being that this one's 4, 1, 0, 4, 1, 9. So it's like the numbers, they're just reversed. And you still get 19 because you're guessing. I think you only had to do one, but that's at least the difference.
Got it. That is it. Thank you.
Sure.
Can you explain in 35A and 39A? I don't understand how to find the formulas.
Okay. Yeah, those are the harder ones. We didn't quite go into as much depth on that. We just kind of ran out of time. But sometimes it's also easier for you to see what's going on. So let's see. 35. The area under that curve from 0 to 1. The big picture. That's 1. That's 1. And the curve looks like that. It's actually a little bit more curvy, but I probably need a little bit of room. So I could guess what the answer is. I know the answer is going to be somewhere between 0 and 1. The area is positive. If I made a big square, that area is 1. This is a lot less than that. It's probably less than a half. I mean, certainly less than a half, because if I do a triangle, it's smaller than that triangle, which would have area half. If I did my fundamental theorem over here with capital F and took the antiderivative, I would get x to the 4th over 4. And now when I plug in those bounds, I'll get 1 over 4 minus 0 over 4. So the answer is a quarter. The overall answer for the area is a quarter. But that's sort of cheap because I want to do it with these right-hand rule and left-hand rule kind of things. So how many things do I chop it up into? Well, if I chop it into 2, then each width would be 1/2. If I chopped it up into 4, each of the widths of these 4 things would be a quarter, or 1 over 4. If I chopped it up into 8ths, each of them would be 1/8, and I'd have 8 of them. 1/8, 1/8, 1/8, 1/8, 1/8. Now here's where you go a little bit more abstract. That if I chop this up into however many I draw, if I chop that up into n pieces, then again, if I chopped it into 2, the width would be a half. If I chopped it into 4, the width would be a quarter. If I chopped it into 8, the width would be an eighth. So if I chop it into n, then the width is just 1 over n. It's whatever, 1 over whatever number of pieces that I chop this thing into. So that's the width for all of these things. The heights are, and this is what we did in class, the first height would be gotten by taking your function, again, this is y equals x cubed, and plugging in whatever that first value is, which would be, if it was half, it would be a half and then 2 copies of a half. If it was a quarter, it would be a quarter, then 2 copies of a quarter, then 3 copies of a quarter, then 4 copies of a quarter. This is, each individual piece is like 1 over n. 2 copies of 1 over n, 3 copies of 1 over n, 4 copies. So when I get all the way to the end, it will be n copies of 1 over n, which is 1, and that would be at the end. So I know that there's no numbers, but you can represent that to be however many copies of things that you have. So the first height, it's really hard to draw these little things in here, but I would go over 1 over n, and I would plug that into the function, and that would be my height. So the first area up here, I can just write it in. So like area 1 would be the width, 1 over n, times the first height, which is 1 over n cubed. And I know this is slightly different than what the book's doing, but I'm just going to come into it a little bit backwards, and we'll see if it makes sense. The second height, which is 2, is I would go over 2 copies of 1 over n, and I would draw that little rectangle. It still has width 1 over n because they all have the same width, but the height would be 2 copies of 1 over n. And therefore, I stick in a cube. So I stick in 2 copies of 1 over n, which is my x value, and then the y value is the cube. So the second area here would be 1 over n, and then 2 copies of 1 over n cubed. Yeah. Is the height. So width, height 1, width, height 2. And I just repeat this process. Is the next one would be the third area would be 1 over n, and it would be 3 copies now of 1 over n would get cubed, get the third height. And I just continue this process of graphs. So I would get with 4 and 4 copies of 1 over n cubed. And I would continue until that very last one, which looks like this. That one there would still have width 1 over n. The height would be n copies of 1 over n cubed is the last one. You can see that that number there is 1. So it does make sense if I go to the very last x value, I get 1 and then I cube it. So this is often the hardest part, is to come up with this kind of idea using numbers or letters instead of numbers. I'm not crazy that way, but let's see what we can do with this. If we can get that set up, then we can note that all of these terms have a 1 over n in front of them. So we want to factor that out. So 1 over n is factored out. And what do I have left? Well, if I factor it out, I'll have 1 over n cubed. That's this term here. If I go to the second one, if I factor this 1 over n out, I'll get 2 copies of 1 over n cubed. And then I'll get 3 copies of 1 over n cubed. And I'll go all the way across, 4, 5, 6, however many I have. The last one will be n copies of 1 over n. So that looks a little bit nicer. There's not as much jumble in there. I've got these 1 over n. They're all the widths. So in the book, they call this width actually delta x. So if you see that, that is the delta x, the width of each of these individual ones. It's just 1 over n. All right, what else can we do? We could cube everything. So this would be 1 cubed over n cubed. I'll just get 1 over n cubed. The next one will be 2 cubed times 1 over n cubed. So I can cube the 2 and I can cube the 1 over n. Then I can cube the 3 and I can cube the 1 over n. And I can do it for 4, I can do it for 5, I can do it for 6. And get to the very end, and I got n cubed and 1 over n cubed. So that's just using power rules or exponential rules. Is that if you have 2 things multiplied raised to the same power, you can just distribute the power on each one. Oh, and correct. This last one here, I should have just done n cubed. So it looks the same.
I actually did have a question. It was on number 19.
Yeah, let's finish this one off. We're almost done, then we can come back.
Okay.
Yeah. Okay, so now we can look again and look, 1 over n cubed, 1 over n cubed, 1 over n cubed. These are all factors of every single one of these terms. So even inside of there, we can do 1 over n cubed can be factored out from all of these terms on the inside. And just for emphasis, I probably should have put in the fact that this is like 1 cubed. So if I factored out, I'd have 1 cubed, 2 cubed, 3 cubed, and n cubed, like that. So I'm just factoring this 1 over n cubed out of every single term. And now I use my formula. So formula time, 1 over n cubed, and then this I wrote down, we didn't use it yet, but if you add up 1 cubed plus 2 cubed plus 3 cubed and you stop at a certain point, the formula ends up being n times n plus 1 over 2 squared. So all those cubes add up together just to be this nice formula, n times n plus 1 over 2 squared, like that. So that's your answer right there. Maybe we can clean it up just a little bit. I think we can. These two things can combine to be 1 over n to the 4th. And this guy, we can square everything out. So that's n squared, n plus 1 squared over 4. Now we're just trying to clean up with our formula so we can use it a lot easier. We have n squared on the top, and we have n to the 4th on the bottom. So we can cancel this n squared. And we can cancel this 4 to become a 2. And we can just stack everything up. So we'll have n plus 1 squared over 4 times n plus 1, or n squared, like that. And that'll give me my formula. If I know how many rectangles or how many pieces I'm using, I can just straight up stick it in there, and I would get the answer for my approximation to the area. So that's at least the answer for part A. For part B, you just plug in n equals 10, n equals 100, and n equals 1,000, and get 4 different answers. And the last one, maybe on part C, is like really going way back. If you take the limit of this guy as n goes to infinity, now you have to go back and go, how do you do that again? Well, if you plug in really big numbers, you could see it that way. If you did, I remember, did we do L'Hopital's rule in Calc 1? Was that in Calc 1?
Mm-mm. No, sir.
It was not?
No, sir.
Okay. I think it might, well, okay. Maybe it's coming up later. But if we did that, the answer is this turns out to be a quarter. So as you plug in bigger and bigger and bigger numbers, this whole thing looks closer and closer and closer to a quarter. And we already know that that's the answer. And so as we put in more and more rectangles in here, then this thing gets closer and closer to a quarter, which is the actual answer. So that's a lot. And trying to get that all pieced out and trying to use the formulas on that properly, it takes some time.
Thank you.
Okay. All right, what else? Did you, Kyle, you said you wanted to do a different one, or would you just want to?
I had a question on number 19 because I looked in the back of the book to see what the answer was when I finished the problem, and it's somehow 1,045. I don't understand how anyone got there.
Okay.
Because the numbers, when I add them up all the time, they seem to be much greater than that, like in the 5,000 range. Yeah, I might be making a mistake somewhere, but I don't believe so, at least.
Okay. Yeah, if you were to just straight up work this out, you plug in I equals 1 and to the pattern, and that'll be your first number. So you plug in 1 and you should get 1, right? Because it'll be 3 and 2, and you subtract it. So that's what you get when I is 1. When I is 2, plug in 2. You don't have to do this, but just sort of to remind you of what this really means.
Okay.
You get 4 times 3, so that's 12, minus 4, so that's 8. So that would be the second number that you're adding on. And you just continue along until you get to the last number, which is 10. And that number will be 10 squared, so that's 100, times 3, so 300. So, and this number will be 2 times 10, so that'll be 20. So 300 minus 20 would be 180. And you'll have 10 copies of that. So I think you probably made a mistake if you added this up. You can't get bigger than like 1,800, right? Because there's only 10 numbers there, and the biggest.
I think I see my mistake now. I think I see it now. It was something I was typing wrong in the calculator.
Okay.
Okay, but I did actually have one question on number 15. That was the one I actually really had a question on, though, or the one that actually I was confused by, as I wasn't entirely sure what the rate or difference was in each time. As apparently when it goes to 1/2 or 2/3, it seemed to be going jumping from 0.16 to 0.09 to 0.05. It wasn't exactly sure how to write that into a formula.
Yeah, so I think that this is definitely a time where you don't want to turn these into decimals. You just want to keep them as fractions.
Yeah.
So the idea is you want this to occur when I is 1, you want this to occur when I is 2, this to occur when I is 3, and this to.
Wait, should I have converted each one of them into the same kind of denominator and fraction and go from there? Sorry.
You could. I think the pattern might be a little bit harder if you do that. If you want to write this as a sum, you do want to have 4 terms, so at least you make your counter go 1, 2, 3, 4. And then just look, right? I mean, if I is 1, I want to get 1/2. If I is 2, I want to get 2/3. If I is 3, I want to get 3/4. If I is 4, I want to get 4/5. So you can see that I is already on the top, right?
Mm-hmm.
And the bottom is just 1 more than that. So if you set the pattern on the top to be I, and you set the pattern on the bottom to just be I plus 1. That's
Oh, actually, does make sense now that I think about it. Oh, it's kind of simple. Oh, wow.
Yeah.
Okay, well, that's the only one I really had a question on. Thank you, though.
Okay.
Sir, can you please show me how to work number 39?
Yeah. Now we're getting to one of the more complicated ones. 39. All right. So once again, I probably should draw a picture. And it does go from -10, 10. 5 minus x. Okay, so that means I go up to 5 and I make a diagonal slanted line down. And just for kicks, if I put in the endpoints here, so again, I'm doing y equals 5 minus x. If I plug in -10, that'll be 5 minus a -10, so I'm up here at 15. If I plug in 10, and down below here, the -5. So, yep, I blew it. So the way to do it, if you blew it, is just make that point bigger and then just change the hash mark. Oops, okay. So the overall answer to this, if we just were asking, well, what is the exact answer? It would be the area under the curve, or above, that would be positive area, and this stuff down here would be negative area. So we can figure out where this crosses at 5. So this big rectangle here is 15 wide and 15 tall. So that area there would be 1/2 of 15 times 15. This one down here is 5 over and 5 down. So that area would be 1/2 of 5, 5. And so then the total answer, which we're calling signed area, would be everything above. So that's 1/2 of 15 squared minus everything below, which is 1/2 of 5 squared. And let's see, 15 squared is 225. So that's 225 halves, and this is 25 halves. So this should, I think, be 200 halves. So the overall answer is 100. So when we work this out, hopefully my answer is going to be close to 100, and then the end actually equals 100. So that's maybe more than you wanted to know, but that's all right. That's the setup. So 10, and now I want to do this using the right hand. And I'm just going to skew it a little bit so I can fit it all up here. Then what I'm going to want to do is chop my interval into a bunch of pieces. I think you can see that if you chopped it into just 2 pieces, like here and here, each of those would be 10 units wide, because it's 20 units total from -10 to 10. If you chopped it in half, then it would be 20 divided by 2. And that'd be 10.
So 10 little pieces on each side.
What's that?
10 little pieces on each side. That makes it 20. Like the 10, like when we break it down.
Yeah, if I was going to break it down into just 2 pieces, then I would have this piece and I would have this piece. And that would be 10. 10 each. If I chopped it into quarters, then each of those I would take the full 20 and I would chop it into 4 pieces. So it would each be 5, 5, 5, 5, 5. So it would be 20 divided by 4, and that would give me each of these 10. If I chopped it into 8, it would be 20, and I would divide it into 8 pieces. If I chopped it into 1,000,000, it would be 20, and then I would divide it by 1,000,000. So in general, if there are n pieces, the average width, not average, the width for all of those would be 20 divided by however many pieces I have. So the width of all of these things would be that.
Okay.
And in the book, again, they call that's called delta x. So it's a small value. So all the widths will be delta x. Okay. The heights of these things is going to start to get a little bit more tricky. For height 1, what I need to do is I need to go over to this first point right here, go up to the curve, and now give me my height. And when I make the rectangle, the width will be delta x, or this width. The height will be to plug that point right there into my function 5 minus x. So it's going to be 5 minus, and I got to figure out what this point is right here. And the answer is, well, I know this point is -10. That's my starting point. If I wanted to go over just a little bit, then I would say that answer is start at -10 and I add just this enough here. So this will be -10 plus 20 over n. Yeah.
Okay. Plus 20 pieces. Because it's 20. It's
Because it's
20 of
20.
them. It's still gonna be 20.
Yeah, because it's 20 wide, and I have n pieces.
Okay.
Yeah. Height 2, I'd have to go over 2, go up to the curve, make the rectangle there, which means I would be taking my function, 5 minus whatever that x value is. And it's going to be, I start at -10 and I go 2 copies of that. So -10 plus 2 copies 20 over.
And I did that, and I do that until the height reached 20. So like the height reached 10.
It would be, let's see, the last height, or yeah, so height 3 would be 5 minus, I go minus 10, plus 3 copies of 20 over 10, and then keep going until I get to the last height, which is actually the nth height. It would be 5 minus 10 plus n copies of 20 over 10. Which makes sense, because if I came all the way over to the end, how far down would I have to go? And the answer is, well, I know that this is down here at minus 5. Does that actually work out? Cancel the ends, and this is going to be 20. I have a negative 10 plus 20, so that gets canceled out. That's 10. And then I'll have 5 minus 10, which is negative 5, which is what I expected that last one to be, all the way over here on the right. So in order to make this work, I have to take all of these things. I got to multiply each one by the width so I can get area 1, area 2, area 3. So width times height for all of those. You want to keep going?
Yes, sir.
Okay. Oh, let's see if I can do this. Continue. So the area of the rectangles will be area 1, so that'll be the width, which is 20 divided by n, times the first height, which is 5 minus, I'm just recopying from the previous page, that's minus 10 plus 20 over n. Catch me if I'm doing it wrong. I don't think I will. So that's that. The second area will be the width. That's that. Times, times the second height, which is 5 minus negative 10 plus 2 copies. I think I'm already drawing too big here. But, maybe do one more. Area 3 will be the width, and the height, which is 5 minus negative 10 plus 3 copies. 2. Missing some parentheses on here. All right, I'll put it around here. And then I'll keep adding until I get to the very end. The width times 5 minus 10 plus n copies of 20 over n. And so, I mean, technically that's my answer. It's not real useful yet because I still have this dot, 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 which means add forever. So I got to come up with some sort of pattern in here if I can. So first thing to notice is that 20 over n, 20 over n, 20 over n, all these 20 over n's are multiplied by every single term. So I can factor that. That's the first thing I can do. Now, hopefully, if it's not too, let's see, hopefully this will be too confusing. That by, maybe I won't do that yet. I want to distribute this minus on all of these things because look what do I have? I've got 5 minus a minus 10, so that's 15. This is also 5 minus a minus 10. And this is 5 minus a minus 10, and this is 5 minus a minus 10. So if I just condense this down, I'll have 15 minus 20 over n. That's, I distribute the minus, and then I put the numbers together to get 15. This one here, I'll get 15 minus 2 copies of 20 over n. And then I'll get 15 minus 3 copies 20 over n. All the way down to the end where I'll get 15 minus n copies of 20. So that looks a little better, for sure. Now if I group here, put all the 15s together. So I got 15 plus 15 plus 15 plus 15 plus 15 plus 15. How many 15s do I have? Well, I've got 1 for each one, and I've got n of them. So if I put all the 15s together, I'll have n copies of 15, which is just 15 times n.
Mm-hmm.
Now, dealing with the other one, every single one of these things has a negative 20 over n, negative 20 over n, negative 20 over n, negative 20 over n. So if I factor that negative 20 over n out from the rest, what's left? Well, I have 1 copy of that here. I've got 2 copies of it here, and it's plus because I pulled the minus out on here. I've already factored it out. I get 3 copies of it, 4 copies of it, and then the last one is n copies. And if this doesn't make sense, you can distribute it back out, and you can group and get all the way back up to that. So we have this magic thing. Now, the point of this section is that this right here, I have a formula for a pattern. So if I use a formula, I'll get 20 over n. This is 15n minus 20 over n times, and now I put my formula in there. And 1 plus 2 plus 3 plus up to n. If I stop at n, that formula is n times n plus 1 divided by 2. So that's the only thing I change is all this sum turns into this nice little fraction.
I think I got it.
Yeah. So I have enough room. Let me put that down below. Now, all right, so let's clean it up here. 20 over n. I've got, what can I do with these fractions? Well, I've got n and n. Cancel them. I've got 20 and 2. Divide. So I'll have 15n minus the 20 over the 2 becomes 10. Those n's cancel out. And I'll have 10 times n, and the n plus 1 is still there. All right, so almost there. 20 over n. Distribute this minus 10, and then combine these terms. I got 15n. If I distribute this, I'd have negative 10n. So that's 5. If I distribute this negative 10, it doesn't cancel out with anything. I just have minus 10 left. So if I distribute this minus 10, I get minus 10n and minus 10. The n's can combine to be 5n. The 10's is left over, we get this. So I'm going to do one more thing where I just distribute this through. So if I distribute 20 over n times 5n, then what do I get there?
100n over n, so 100.
There we go. Then I can cancel the n. So 100n over n, cancel the n's, and I get 100. This one, if I multiply 20 over n and distribute here, I'll have 20 times 10, which is 200 on the top, and I'll have n on the bottom. And that's part A. That's the end of part A.
That's so long, sir.
I know, yeah. Now, the nice thing, at least about part B, is all I got to do is stick in 10, and then 100, then 1,000 in here. And then just calculate what that answer is. And the nice thing is on part C, if I take the limit of as n goes to infinity of this thing, then if I plug in larger and larger and larger numbers into the denominator of a fraction, that gets smaller and smaller and smaller and smaller and smaller and smaller because the denominator is getting bigger and bigger and bigger and bigger. This term ends up getting canceled out eventually. And so the overall answer, the exact answer, the exact area answer is 100. But guess what? We already knew that the answer was 100 because it's a big triangle minus a small triangle. Without going through all that crap, we could have just used some geometry and got the answer right off the bat. But it's a math class, so you got to have some pain at some point. So a very long answer to a question that, I think that's close to one of the longer answers for any of the homework for the whole class.
That helped me, sir. Thank you.
All right, we preload that. So, all right. So we still have a few more hangers on. Hopefully that kind of stuff helps you there. Probably have time for one more short one. If someone had a question, we could do that.
I'm all good. Thank you, sir.
Okay, see you, Steve.
Thank you, sir.
All right, have a good afternoon. All right, so why don't you guys, finish up the homework. You still got some time here, almost an hour and a half, and get that in. And if you have last minute questions, maybe just text me so I don't have to sit here in front of Zoom. And,
Yes, sir. So, sir, at first, like when you use the fundamental theorem on the first part, without starting to do to use the area of the rectangle, did you multiply the big triangle of number 39? Did you multiply that area times the small triangle area? Yes.
Yeah,
Yes,
so
sir.
all I did was just notice that it's 15
Yeah.
wide and 15 high, and just did 1/2 base times height.
On the big triangle, it was 15 times 15. 1/2 times 15 by 15.
Correct.
Okay.
And then I just combined the 15s into 15 squared. So 15 times 15.
Got it. 1/2 times 15 squared minus 1/2 times 5 squared. Got it, sir. Thank you.
Okay. All right. Have a good afternoon.
You too, sir. Thank you.